Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. So I recently got a comment from YouTube user PJ Nutting4550 saying that he had looked at my video that I did about initiative in combat. Initiative being where you determine who gets to move first. And I had a quite simple system where either all of the player characters get to move first, get to attack first, or all of the enemies get to attack first. And then once all of one side has gone, the other side gets to go. And he wanted a system where every character, whether player character or enemy, has their own initiative score. So it could be that a particular enemy goes, and then a particular player character goes, and then maybe another player character, then another couple of enemies, or whatever it may be. So I've programmed a system like that, and this video is going to be showing you that system and showing the code for how it's done. So thank you for commenting, PJ, and if anyone else wants anything, just comment on any of the videos. If I can do it, and if I understand exactly what I'm meant to do, and if I'm able to do that, then I will do it. So let's first have a look at this. So what I've assumed is that we don't want it to be totally random. We want different characters to have a different sort of initiative ability. That is, there are some characters that are more likely to go first, and there are other characters that are sort of less perceptive or something and would tend to go later on, but that there's also an element of randomness. If that's not what you want, it's quite easy to get rid of the randomness or to get rid of the player scores, but I would suspect that most people who are interested in this topic will want, say, if you've got an assassin or someone, a character that's kind of really alert, they're probably going to move first before a fairly low-level monster, for example. Whereas a character that's not so combat oriented, a merchant or something, well, they might have a lower score. So what I've done is I've assigned scores to the player characters and to the enemies quite arbitrarily. There's no attempt to match the picture to the score. It's just a demonstration. And these are their sort of basic scores, and then we will determine their initiative for the combat. Basically, there is a variable which says how much randomness there is. It can go up or down by a certain amount, and that's encoded in the variable R for randomness, of course. And if you find the results too random, well, you can just decrease R. And if you find the results not random enough, if you find that the same things are happening each time, then you can increase R. You can also set it up so initiative scores are closer together, and that will tend to make things more random. And if you have initiative scores further apart, that will make it more random. I've assumed that it's on a percentage scale, so the maximum's 100 and the minimum's 1, something like that. So we've got these scores, and then we press the button to determine individual initiative. This button could be a link. I just thought a button looked a bit better. It functions exactly the same. But when we click it, we now see that they've changed, but that they sort of tend to be in roughly the same order that they were. So this guy's got 121. He had a basic score of 100, and this guy's got a negative score, and he had a very low score to start with. And also these scores tend to get bigger as you go to the right, and that's how their initial initiative scores were. So it's random, but it's also based on based on a sort of basic score. There's certain people who will tend to get better scores. And so once we've got all these scores, it the system says, well, who's got the highest score? Well, it's this guy, player character number 4. So it says player character 4 will now act. And because this is just a demonstration of initiative, he won't actually act. I haven't programmed the choosing the enemy and the hitting and the damage and etc. All that will happen is you go to his initiative is blanked out because he's considered to have gone, and now we see, well, who's got the highest score of what's left? Well, it's enemy 4 who's got 99, so it's now his go, and so on. It'll be his go, and then his go, and then his go. It looks like, yep. And then player character 3 goes, and then enemy number 3 goes, and so on. They go down the order. So all the enemies have gone now, and now the last player character goes. The last 2 player characters go, and then it says all characters have now acted. And if this were a real game, of course, you would start a new round, and you might decide to re-roll initiative each round, or you might decide to just roll initiative once for the combat, and that's the order. But either way, that's how it works. So let's have a look at the code. We get in here. So the basic structure of the program is that we set up the variables, as always. Normally I call this page initialize, but initialize, at one stage I had a page called initiative, and I didn't want to have 2 that had very similar names, so I've called this page variables, where I normally call it, I would normally call it initialize. Then we have pre-display, which is just the display of the basic initiative scores. You'll notice there's no arrow leading out of this. That's because I'm using a button instead of a link, and buttons don't generate arrows in this display. Then we have randomness, where we apply a little bit of randomness to, well, yeah, as it says, we apply randomness to the basic scores. Then we have the sort of main loop of a round, which is work out who's next, display what's happening. This is called act. This is the page where the action would happen. This is the page where you would have the roll to hit, and then the roll for damage, and then that makes the character dead. And if it's an enemy, we'll work out who it's going to hit, and so on. And then we go back to once they've acted, we go back to who's next and work out who goes after that, and then we go back to the display and we display it, and so we keep going. Again, there's no arrow between this one and this one, but actually this one does lead to this one with a button. So we go around in this loop until everyone's had a go. So let's look at the. Actually, sorry, before I do that, the first thing that I always do, I don't always remember to say this, but the first 2 things that I always do is I go to, is it JavaScript? Yeah, I go to JavaScript and I put this config.passages.nobreak, N-O-B-R, equals true, because if we don't put that in, we'll get all of these line breaks that we didn't mean. Every time we have a line break in the code, it'll count that as a line break on the screen, and that's not what we want. Doing that makes it very difficult to lay things out in a easy to look at way, because we want lots of line breaks to separate different things. I do that, and I go to details, and I think it's on Harlow by default, but it's certainly not on Sugarcube by default. So I go down here and I choose the latest version of Sugarcube, because if we don't do that, then none of the commands will work properly, because we'll be using a different, we'll be using Harlow, which is a different format, and essentially it's a different language. So I always do that, but I don't always remember to point out that you need to do that to make any of the rest work properly. So let's have a look at the initiative. There we go. I'm trying to zoom in. Okay. So first array that we have is $C, and $C is the number of characters on each side. Specifically, $C0, we've decided that there's 4. That's the number of player characters. And then $C1 is the number of enemies. And of course, if you were in a real game, both of them would go up and down. The number of player characters would typically would start at a high number, and then occasionally you'd lose some that they'd be killed in combat or something, and you might hire new ones or recruit new ones. And then, of course, the enemies would be different each time you fought a group of enemies. So we have C, which is the number of characters, C for characters. We have I for initiative, and then we have T for temporary. So I is more like what's on the player's character sheet, or what would be on the character sheet if it was a tabletop game. It is their basic initiative score, and then the temporary initiative score is that basic initiative score with randomness applied. And again, it's divided into I. It's a two-dimensional array this time. So I0 is the player characters. So for example, I02 or $I square bracket 0 n square bracket 2 n square bracket would be this number here, and that would be the second player character's initiative score. And then similarly for the enemies. So I just gave them 20, 40, 60, 80, and 90. In a real game of this sort, you might actually not have that much of a spread. You might have sort of all orcs have, this initiative, and all ninjas have high initiative, and all, tortoises or something have a low initiative, something like that. And if you're fighting a single type of monster, they might all have a similar range. But for demonstration purposes, I gave them a nice range. And in a real game, these would be dependent on probably character class or skills, or however it is that you distinguish your characters, their attributes. Perhaps you wouldn't have a separate initiative score. Perhaps it would just be dexterity or some sort of perception or some sort of score like that. And then we have T, and T is structured the same. So T02 is the second player character's modified initiative score. And then we have R, which is the amount of randomness, the maximum change. Basically, this score for each character, whether they be an enemy or a player character, can increase by up to 30, or it can decrease by up to minus 30 or down to minus 30, or a very small chance it can it can stay the same. But anywhere within that range of what it is plus 30 to what it is minus 30 will be the temporary score. And then, as usual, I just write Z, Y, X, W, and V are the temporary variables. So I didn't mean to press. That's just, yeah. So we have temporary variables. So C, I, T, and R are the main ones we're going to be using. And then we go to pre-display. I'm not going to go into this in huge detail. It is very similar to a display that I've already gone into. It's two arrays. Basically, you have one array which has the player characters' pictures in one cell, and then their basic initiative score in the cell below. And then we have the button, which you click to send you to the page randomness, and it has the text determine individual initiative. As I said before, buttons basically do what links do. That with a button, you can put code in between here. You can set it up so when you click the button, do a certain, perform some code, and then go to the page. But so far I found it just as easy to do that code on the next page. So I just use them essentially as the same as if they were just a link that you click. I just think it looks a bit better. And then we have a similar array where we display the enemy pictures and the enemy basic initiative. We have randomness. So So we have two for loops, which go from 0 to 1. Z goes from 0 to 1. And then for each Z, Y goes from, excuse me, Y goes from 1 to $C square bracket $Z N square bracket. In other words, when Z is 0, it will go up to C0, and when Z is 1, it will go up to C1. So basically, Z tells you what side we're talking about. 0 is the player characters, 1 is the enemies, and then it goes through however many characters there are on that side. We set TZY to be equal to IZY. So T is the temporary initiative, the one we're going to be using for just this combat, is equal to IZY, which is the character's sort of basic initiative score that carry. I mean, if it was a proper game, the player character's initiative score would carry on from one combat to the other. And sorry about that, I was waving my hands and I just bashed into the fan. If you heard a noise there. So TZY equals IZY plus a random number, and the random number goes from minus R to R. So because R is 30, it'll be from minus 30 to 30. And I could have just said from minus 30 to 30 and not had R as a variable, but it's easier to find if you have it as a variable at the start, even though that is the only place that R is used. And I could have set it to minus 30 to 30. Like I could have done, I'll show you. I could have just done it like that, and then we wouldn't have needed R. But then I want it to be, especially because in a real game there'd be a lot more code than this. I wanted it to be as easy as possible to find where that amount of randomness is. And so you can just go to the start of the, go to the page where all the variables are, and you say, well, that's giving me two swingy results. I actually want it 20 instead, or conversely, that's actually quite boring, and it ends up being the same every time, and I want it to be a bit more random, so we use 50 instead. All right, so having done randomness, having given everyone a score, a temporary score, what we're going to do now is count down the initiatives. So we set Z equal to 100 plus R. The reason it's 100 plus R is because I've assumed that initiative scores are on a scale from sort of 1 to 100. 100 is like the maximum that anyone can have. And if 100 is the maximum that anyone can have, then 100 plus R is the maximum that anyone can get in the T array, because that would be the maximum value for initiative plus the maximum roll in this randomness, which would be very unlikely, of course, but it could happen. So that's the maximum. And what we're going to do is count down the initiative. So we'll start at 130 and we'll say, does anyone have 130? If so, they get to act. Okay, nobody does. What about 129? No. Okay, what about 128? No. What about 127? Now, of course, in real life, doing that on a tabletop, that would be very tedious. And most commonly, you would have a much smaller range of initiative scores. So you might have a 20-sided die being rolled, and then only a few points of modifiers. And that way, if you count down the initiative, there's a lot less. So you can say 20, no, 19, okay, etc. But because this is a computer, it'll go really fast. So we can have, we can start at 130 and count all the way down, and it'll be fine. It'll be quick. So having given everyone their initiative and having set Z to be the highest possible result, we then go to the page Who's Next. This is very straightforward. We set X and Y to 0, and if we find a character who has the initiative that we're looking for, which is Z, then we're going to put that character's details into X and Y. So it'll be the character, the side will be Y, so that will stay as Y, stay as 0 or become 1. And then X will become between 1 and 4 if it's a player character, or 1 and 5 if it's a monster. If the monsters or characters had a different number, it would be 1 to whatever that is. So it'll be character number X of side number Y. And so we have a a for loop, which is W and V. W goes from 0 to 1, and V goes from 1 to $C square bracket $W n square bracket. So you'll notice that this is the same range as we're using here, but we have different temporary variables because Z and Y are in use now. So instead we use V and W. So go through every character is basically what these two lines mean. And then if X is equal to 0 and TWV is equal to Z, in other words, if they have the initiative that we're looking for, and if X equals 0, meaning if we haven't found a character yet who has the initiative, then we set Y equal to W and X equal to V. So we store these in X and Y. Character number X of side number Y. The reason we use X equals 0 rather than if Y equals 0 is because Y can sometimes equal 0 even after we've done this, because Y is either going to be 0 or 1, because whereas X is always going to be 1 or more. So that's why we look at X specifically. So go through all of the characters, and if you find one that's got the initiative that we're looking for, store the details of that character in X and Y. So at the end of that loop, one of two things will be possible. We've either found someone or we haven't. And if we haven't found someone, then X will be equal to 0. So we have an if else. We have if X equals 0, then do all this code, else, end if. So if X is equal to 0, meaning if we haven't found anyone, then reduce Z by 1. So, okay, we haven't found anyone who's got 130. Well, let's try 129. Let's set Z to 129. Now, what if Z is equal to minus R? Well, if Z is equal to minus R, that's the lowest, or actually it's lower than the lowest. If we assume that 1 is the lowest possible initiative score, the lowest possible temporary score anyone could get would be 1 minus R. So if Z equals 0 minus R, then we know that we've definitely gone through everyone. Everyone should have had a go, unless there's something wrong with the code. So if we get to minus R, then we set W. W is a message that we're going to display on the next screen, which says what's going to happen, basically. So set W equal to end, and then we go to post display. Post display is this one here. We have pre-display and post-display, which look very similar but are separate pages. As in, they look very similar to the player. If we haven't found anyone, well, let's reduce Z by 1, and if we've gotten to the end, then there's no point continuing to look. So we set W to be equal to end, and we go to the post-display page. Otherwise, there is a point continuing to look. So we include who's next. In other words, we go back to the top of the page. So we might start at 130. Almost always no one will get 130. So we will search all through every character looking for someone with an initiative of 130. We won't find them, so X will be equal to 0. So then we'll set Z equal to 129 instead. And then we'll go back to the top of the page and try again. And of course, most people probably won't have 129 either. So we'll go through that, and then, because the computer processes things so fast, this only takes a second or so. It doesn't sort of sit there. It takes a lot longer to explain it than it does for it to actually run. So it'll zoom around until it finds someone who's got the initiative that we want. Eventually, Z will get low enough that someone will have the initiative we want. So that'll be what happens here at the other end of the if x is equal to 0 else. Okay, so now we have to set w, which is the message. As I said before, this is the one that is set to end up here. If y is 0, then we know it's a player character, so we set w equal to the text player character. And if it's not 0, then it's going to be an enemy. And then we add to that text the number of the character, and then the text will now act. So it'll be something like player character 3 will now act, or enemy 4 will now act, or something like that. And having created that message, we then go to post display. So post display is again very similar. I'm not going to go through the bit where we display the characters and their temporary initiatives, because that is exactly the same as before. But this is and then display enemies at the end is very similar as well. The bit that's novel is the bit that I'm highlighting here, in the bit under the display message comment. So you'll remember we've come from the previous page with something stored in $W, which is either a message like enemy 3 will now act or something like that, or it's the text end. If it's end, then we just say all characters have now acted. Otherwise, we print W, we say enemy 3 will now act, or whatever it may be, and we have a button to continue. Of course, we don't have a button to continue if all characters have acted. In real life, we would, because a new round would start unless everyone was dead. But because this is just a demonstration, it only goes through one round. So we have a button, and the button has the text continue and will take you to the page act. Again, this could have been a link, but I thought a button looked better. Act, if this was a real combat, this would be where all the rolling to hit and stuff happens, but because it isn't, because it's just a demonstration of individual initiative, we set the temporary initiative of the character who has supposedly acted to be equal to dash dash. In other words, it's sort of blanked out because their initiative, they've gone, they've had their go. And that means that when it prints, you will notice that the characters who had had their go, it just had a long dash printed there. And then we go to who's next. So, of course, we've seen who's next. Now we're going to go and see if there's anyone who has that initiative. Now, you may have noticed that we only decrease Z when we haven't found anyone. We don't decrease Z when we do find a character. This set Z minus minus is only within the code. It's only within the condition if X is equal to 0. If we do find someone, we don't decrease the initiative. And the reason for that is there's a small chance of a tie. It's a very small chance. I don't think I've got a single tie any time that I was testing this, but technically, of course, it could happen. And what I decided to do was just the first one that you find gets to act first. So in this case, player characters, if there's a draw, player characters will act before enemies, and within the player characters or within the enemy, the monster or character with the lowest order in the group will go first. So character 2 would act before character 3 if they had the same initiative. But because there's a possibility of a tie, we don't reduce Z if we find someone, because then we'd miss the other people who had the tie. Now, you might want, instead of just saying, well, the player characters can go first and the character that's first can go first, you might want to have a set of code to break that tie and to make it truly random. I found that the amount of code you'd have to add to do that probably wasn't worth the corner case of that happening, and it was probably fine to just give these player characters this small advantage and give the lower numbered characters a small advantage. But if you want me to add that to break ties, then let me know and I'll do a video on it. But that's the entire system. We have every character has a sort of basic initiative score. We display that. We get them to click through. We apply randomness to that basic score. Then we go through every possible result from the top to the bottom. We find someone who can, we sort of go around this page until we find someone who can act. Then we display and say, yep, they're going to act. And then we set their initiative to be sort of finished. And we go back until we've either found someone else or gone through every possible initiative rank. And either way we display, we say, okay, the next character is going to act. And then at the end we say, right, everyone's had a go. So that is one way to do individual initiative. So I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.